गुड मॉर्निंग स्टूडेंट। अभी तक हम लोगों ने फर्स्ट चैप्टर इलेक्ट्रिक चार्ज और इलेक्ट्रिक फील्ड में कुछ जो टॉपिक्स लिए थोड़ा रिकॉल करते हैं। चार्ज, टाइप्स ऑफ द चार्ज, टाइप्स ऑफ द क्वांटाइजेशंस, definition of the quantizations, electroscope, up quarks, down quarks, charging by the inductions, Coulomb's law in the vector form and the scalar form, and the superposition principle, electric field due to the point charge, the definition of electric field lines, characteristic of electric field lines, electric dipole, electric field due to the dipole at the axis and equator. And the next topic, flux. Now, what is the flux? Flux phi is equal to E dot A means the flux is scalar product of the electric field and area is known as flux. Okay, now the dot product means this is the EA cos theta. Now the phi is equal to EA cos theta. Here theta is the angle between the E and A. Special cases लेते हैं. If the theta is equal to 0, if the theta is equal to pi by 2, if the theta is equal to pi, we get the maximum value, the minimum value of the given flux. Okay, now we start the new topic, that is the Gauss law. Means Gauss law associated with the given surface. The integration of electric field over a closed surface which enclose the charges leads us toward the Gaussian law. Gaussian law is the fundamental laws of natures. अब इसे प्रूव करने के लिए now we consider a sphere. The radius of the sphere is r. पॉजिटिव चार्जेस रखा गया सेंटर पे. ओके, now we find the flux at this small area, and the area is dA vector and the electric field is E. Consider a point charge plus Q located at the center of given sphere. The radius of the sphere is R. Now we will determine the total flux linked with the given surface of the sphere. According to the definition of the flux, total flux linked with the surface, the phi is equal to given surface A into dA vector. The closed integration A dA cos theta means given surface, or closed integrations means given closed loop. Okay, all the points on the surface are at the equidistance from the center. Hence, the magnitude of the electric field will be same at the every point at the surface. The electric field due to a point charge is radially outwards. Hence, area vector dA. Hence, the area vector dA of each surface element will be along the direction of E vector. If the maximum value of phi means if the theta is equal to 0, that is cos 0 is equal to 1. The phi is equal to integration of E into dA. Okay. Now, इलेक्ट्रिक फील्ड, अब पॉइंट चार्ज एट द सेंटर, इलेक्ट्रिक फील्ड सब जगह पे कैसा होगा, सेम होगा. सो दिस इज फाई इज इक्वल टू ई गिवन सरफेस डी ए. नाउ द इंटीग्रेशन ऑफ डी ए, that is capital A. Now the capital A means the area of given surface. Now the area of given surface, that is A, is equal to 4 pi r square. Now E is the electric field due to the point charge. electric field due to the point charge, that is kq by r square. Now this is the kq by r square, and the area of sphere, that is a 4 pi r square. R square cancel out. The pi is equal to k is equal to 4 pi epsilon 0 into 4 pi. K is equal to 1 upon 4 pi epsilon 0. Now the 4 pi cancel out. There, therefore, total flux phi is equal to q upon epsilon 0. Here q is the total charge associated with the given surface. Now, the Gaussian law, from this statement, the total electric flux associated with any closed surface is equal to the ratio of the net electric charge enclosed by the surface epsilon 0. Means the phi is equal to closed path E into dA vector is equal to sigma q upon epsilon 0. This formula represents Gaussian law. Means again, the Gauss law statement, the total electric flux associated with any closed surface is equal to the ratio of net electric charge. The ratio of net electric charges enclosed by the surface to the epsilon 0. This statement is known as Gauss law. Now, the law implies the total electric flux through a closed surface is 0. Let us note down some important points regarding this law. The first one is what? Gaussian law is true for any closed surface, no matter what its shape or size. The second point is what? The terms Q on the right side include the sum of all charges enclosed by the given surface. The charges may be located anywhere inside or outside the given body. The electric field appearing on the left hand sides of the given equations, the electric field produced due to a system of the charge. Now, the most IMP, the total flux is the phi is equal to sum of, means that is a q1, q2 up to qn upon epsilon 0. Here epsilon 0 is free space permittivity, and the magnitude of this free space permittivity is 8.85 into 10 raised to minus 12. Now, the application of this Gaussian law. The mainly three types of the applications. Application means that is the uses of this Gauss law. Again, what is the Gauss law? Gauss law is the phi is equal to closed integrations E into dA is equal to sigma q by epsilon 0. The first application of this Gauss law, और एक चीज याद रखना, हम गॉस लॉ के थ्रू जितनी भी एप्लीकेशंस है वी फाइंड द इलेक्ट्रिक फील्ड. बेटा एक चीज याद रखो कि जो भी हम गॉसियन लॉज का यूज करेंगे उस सब में इलेक्ट्रिक फील्ड फाइंड करना. द फर्स्ट एप्लीकेशन इज इलेक्ट्रिक फील्ड ड्यू टू एन इंफिनिटी लॉन्ग स्ट्रेट यूनिफॉर्म चार्ज वायर. Again, the electric field due to an infinity long straight uniform charge wire. Suppose I have, this is uniform, this is the axis, this is the point P, the radius of this wire is R. that is the dA, and the direction is E. Now at the end of this wire, this is the direction of dA and this is the direction of E. एक चीज और बेटा याद रखना, इलेक्ट्रिक फील्ड हो या मैग्नेटिक फील्ड हो, डायरेक्शन ऑलवेज परपेंडिकुलर टू द गिवन सरफेस. ओके. नाउ an infinity long and linear charge distributions having the uniform linear charge, the density is lambda. Now the linear charge density, अच्छा ये सारे एप्लीकेशन जब भी हम यूज करते हैं बेटा तीन चीजें याद रखनी है. That is the linear charge density. Lambda is equal to Q by L. Now what is the linear charge density? Charge per unit length is known as the linear charge density. Area charge density, that is the sigma, is equal to Q by A. Charge per unit area is known as the area charge density. Volume charge density, that is the Q by V. Charge per unit volume, that is वॉल्यूम चार्ज डेंसिटी. ऐसा यूनिट तो डायरेक्टली फाइंड कर लेंगे, कूलम पर मीटर स्क्वायर, कूलम पर मीटर क्यूब. एक चीज याद रखना है कि जितने भी एप्लीकेशंस हम लोग गॉस लॉ के लेंगे, सबसे पहली चीज फाइंड करना है इलेक्ट्रिक फील्ड. दूसरी चीज उसमें इन चीजों का यूज करना है. मींस दिस इज द फिजिकल क्वांटिटी ऑफ द लीनियर चार्ज डेंसिटी, एरिया चार्ज डेंसिटी, वॉल्यूम चार्ज डेंसिटी. जब हम फर्स्ट एप्लीकेशन की बात करते हैं, मींस इलेक्ट्रिक फील्ड ड्यू टू एंड इनफाइनाइट लॉन्ग स्ट्रेट यूनिफॉर्म चार्ज वायर. हम जब एक यूनिफॉर्म चार्ज वायर की बात करते हैं तब यहाँ पे हम लैम्बडा का यूज करेंगे. मींस as the infinity long and the linear charge distribution having the uniform linear charge density is lambda as shown in figure. We want to find the intensity of the electric field at given point. We want to find the electric field at given point. ठीक है. अच्छा इसमें और क्या करना पड़ेगा, अगर मैं यहाँ फाइंड करता हूँ या यहाँ फाइंड करूँगा, सबकी जगह रेडियस क्या है सेम, तो इलेक्ट्रिक फील्ड कैसा मिलेगा, सेम मिलेगा. ठीक है. Since the wire is infinite length, the electric field at the all points like the P, Q, हम कितने भी पॉइंट्स लेंगे, इलेक्ट्रिक फील्ड कैसा मिलेगा आपको, यूनिफॉर्मली मिलेगा. और द इलेक्ट्रिक फील्ड लाइन इज द परपेंडिकुलर टू द एक्सिस. ओके. नाउ imagine a cylindrical Gaussian surface of radius r and the length l. हमारे पास infinite वायर है, इसकी जगह क्या कंसिडर करते हैं. Now imagine a cylindrical Gaussian surface of the radius r and the length l. Okay. अगर मैं लेंथ l लेता हूं, now the surface of this cylindrical is 2 pi r l. Means the surface of given length, that is a 2 pi r l, and the cross section of the area is pi r square. But again ध्यान से सुनो, the area of this curved surface of the cylindrical is 2 pi r l and the cross section area of this cylindrical is pi r square. The charge enclosed by the cylindrical of the length L is Q is equal to lambda L, because we know that the lambda is equal to Q by L. Okay. As shown in figure, the electric flux associated with the cylindrical surface of the radius r, length is capital L. According to the Gaussian formula, the phi is equal to close integration E into ds or dA. Now हम सबसे पहले फ्लक्स ले लेते हैं phi 1. Now what is the phi 1? अगेन बेटा याद रखना, as shown in figure, the electric flux associated with the cylindrical surface of the radius r and the length capital L. So that is the phi 1 is equal to E close integration of ds So the phi 1 is equal to E 2 pi r L. Okay, this is the flux associated with the given surface. Now the flux associated with the two ends of side of the cylindrical perpendiculars. Now the perpendiculars means that is the theta. Theta is the 90, cos 90 is 0. तो हमें इन दोनों के पास जो फ्लक्स मिल रहा है वो फ्लक्स कितना मिल रहा है 0. ओके, अब दोनों एंड पे जो भी मतलब फ्लक्स मिलेगा 0 मिलेगा बिकॉज ई और डी ए के बीच का एंगल कितना हो जाएगा 90 डिग्री. नाउ द टोटल फ्लक्स phi is equal to phi 1 phi 2 associated with this end plus phi 3 associated with another end, so this is a 0, so the phi is equal to E 2 pi r L. Again, using the Gaussian law, the phi is equal to close integrations according to the Gauss law. So that is a phi is equal to close integration E into dA is equal to sigma q by epsilon 0. Now substitute these values. Now E 2 pi r L, the phi is equal to 2 pi r L is equal to q by epsilon 0, but the q is equal to lambda L. So the electric field is equal to lambda L upon 2 pi r L. L is cancelled out, multiply with the epsilon 0. The E is equal to lambda upon 2 pi r epsilon 0, means we can say the E is equal to 2k. The k is equal to 1 upon 4 pi, so that is a multiply and divided by 2, so that is 2k lambda upon r. This is the electric field due to an infinite long straight uniform charge wire.